Okay, second part of the notes for today, which is day 5 of our radical unit. We're looking at operations of radical expressions. One thing to keep in mind before we start is when we're adding and subtracting, you can only add or subtract identical radicals. That means they must have the same index. The index is that small number inside your radical, and same radicand. That means what's under the radical sign. So they must be exactly the same for us to add or subtract these. We're not going to do every problem on here, but it's to give you an idea. So, for example, if we had 3 square root of 7 plus 5 square root of 7, they both have the same radical signs and the same radicand, what's under there. So that doesn't change, only the number in front changes, your coefficient. So 3 plus 5 gives you 8. Over here, same thing if we have a cube root. This really is 1 cube root of 4 minus 7 cube root of 4. 1 minus 7 gives you a negative 6. Okay, so let's take a look at some of these. 12 to the 4th root of z minus 5 to the 4th root of z. We've got the same index and same radicand, so we can combine these. 12 minus 7. 12 minus 5 is 7, and we don't change our radical at all. Over here, oh, look at this. This is trying to trick us. 12 square root of 7 minus 5 square root of 7. These two have the same radical and same index. So 12 minus 5 is 7 root 7. These two have the same radicand and same index, so we combine them. 5 plus 6 is 11 to the 4th root of 7. So again, you're looking for things to be the same. And occasionally, we're going to have to simplify first. Okay, square root of 3, I can't bring anything out of there, but square root of 12. 12 we can break into the square root of 4 times the square root of 3. The square root of 4 is 2, so this is really 2 times the square root of 3. Now we have the same index and the same radicand, so 6 square root of 3 plus 2 square root of 3 is 8 square root of 3. I hope that makes sense to you. Let's take a look here. 7 to the 4th root of 48. Oh my goodness. The 4th root of 48. What does 48 break into? Let's see, 4 times 12. So that's 2 times 2 times 2 times 2 times 3. So I've got 4 of these, and that's how many I have to take out since it's the 4th root. This comes out as 2. 2 times 7 is 14 to the 4th root. Oops, you can't read that. So 14 4th root of 3 minus, 243. Let's see if we can break that down. I'm hoping that 3 would go into that. Okay, so this is equal to 81 times 3. And 81 is 3 times 3 times 3 times 3. So I can pull a 3 out of here. 3 times 4 is 12, and I still have that 3 left. So 14 of the 4th root of 3 minus 12 of the 4th root of 3. 14 minus 12 is 2. We don't change our index. So our answer is 2 to the 4th root of 3. Okay, let's come back over here. Can we take out anything? Square root of 63. 7 times 9. So this is equal to 7 times 9. And z third can be broken into z and z squared. 9's, the square root of 9 is 3, so I'm going to take that out. Multiply by the 3 on the outside. And z squared I'll take out as a z. So I'm taking out the 9 and the z squared. So we end up with 3 times 3 is 9, z squared square root is z, and we're left with 7z underneath. Okay, and over here we have plus 28 is the square root of 4 times 7, so the 4 comes out as 2 times 2 is 4z with 7z underneath. Okay, so 9z plus 4z is 13z square root of 7z. Okay. Can we do anything on this next one? All right. So square root of 4x plus 12, can we simplify that? That's equal to the square root of 4 times x plus 3. The square root of 4 is 2, so I'll pull that out as 2 square root of x plus 3 minus, looks like we can simplify this. 9 goes into both things, so 9 times x plus 3. Oh, this looks like it's going to work nicely. Square root of 9 is 3, and we leave the x plus 3 underneath our radical. 2 times the square root of x plus 3 minus 3, x plus square root of x plus 3. 2 minus 3 is minus 1, so we don't need to write the 1. So the answer is negative square root of x plus 3. Let's take a look at multiplying these. When we multiply, we need to distribute. We multiply what's on the outside times the outside, and what's under the radical sign times what's under the radical sign. So square root of 5 times 5 gives you 5 square root of 5 plus, there's an implied 1 there, so 1 times 3 is 3. Square root of 5 times the square root of 5 times the square root of 3 is 15. Nothing we can do with that. That's as simple as it will be. Same thing happens when we are using a cube root. So cubed root of 6 times 3 times the cube root of 2. There's an implied 1 times 3 is 3 times the cubed root. 6 times 2 is 12 plus 1 times 1 is 1 cubed root. 6 times 12 is 72. And we might want to take a look at 72 to see if we can simplify that. So 72 breaks into 8 times 9. 8 breaks into 2 times 2 times 2. So we've got 3 2's we can take out. And 9 is 3 times 3. Well, I need to have 3 of something since my index is 3, so that cannot come out. So we'll rewrite this as 3 times the cubed root of 12 plus, I'm taking those 2's out, 2 to the cubed root of 9. And I can't combine these. The 12 and the 9 are different, so they stay separate. Okay, how about multiplying when we've got a binomial times a binomial? And here we're going to do the same thing we did when we're dealing with polynomials and do FOIL. So the first times the first is 15. 5 times the square root of 6 gives me 5 times the square root of 6. Square root of 5 times 3 is 3 times the square root of 5. Plus the square root of 5 times the square root of 6 is the square root of 30. And then we'd look to see, can we simplify? 6 can be broken down into 2 times 3, but neither of those is a perfect square, so we can't take them out. 5 is a prime, and 30 is 5 times 6. There's nothing I can take out. That is your answer. It's as simple as it gets. Okay, and we would continue doing the same type of thing here when you're multiplying. We've got a couple of special cases here, so I want to take a look at these. So 6 times 6, 6 times this. So 6 times 6 is 36. 6 times the negative 3 times the square root of 2 is negative 18 square root of 2 plus positive 18 square root of 2 plus times a minus is a minus. 3 times 3 is 9. And 2 times 2 is 4. So what happens here? Those cancel with each other, and we have 36 minus, what, our square root of 4 is 2. So 2 times 9 is 18. So 36 minus 18 equals 18. Okay. Same thing will happen over here. We multiply, and again we're doing FOIL. So square root of 2 times the square root of 2 is the square root of 4, plus square root of 2 minus square root of 2 minus 1. These guys cancel. Square root of 2 is 2 minus 1 equals 1. Notice in this case we don't end up with any radicals in our answer. Okay, rationalize. Rationalize means we don't have a radical in the denominator. That's the important thing. To get rid of the radical in the denominator, we need to multiply by it. So to get rid of the square root of 3, I'm going to multiply the fraction by square root of 3 over square root of 3. 2 times the square root of 3 is 2 times the square root of 3. Square root of 3 times the square root of 3 gives me the square root of 9, which is 3. Let's pick a couple other of these. If I want to get rid of this one, we multiply. We don't need to multiply by the whole thing, just what's under the radical sign. So square root of 3 times square root of 3, and we get negative 5 square root of 3 over, again, square root of 3 times square root of 3 is square root of 9. And the square root of 9 is 3 times 2 is 6. Let's do one with a cubed root here. So to get rid of a cubed root, I need to have what would make this have 3 of them. So I have 7. I need 2 more 7s. So 7 times 7 under the cubed root. So on the top we have 5 cubed root, and 7 times 7 is 49, over 7 times 7 times 7. We don't really need to even know what that is, but we want the cubed root of that, so that will be 7. So our answer is 5 cubed root of 49 divided by 7. And let's do this last one, how about? Or no, let's do this one. This is a good one right here. 8 over the cubed root of 36z squared. 36 is 6 times 6. So let's just rewrite this. This is 8 times the cubed root of 6 times 6 and z times z. So to take something out when it's a cubed root, I need to have 3 of them. So I need one more 6 and one more z. So I will multiply by the cubed root of 6z over the cubed root of 6z. And I get 8 times the cubed root of 6z over the cubed root of 6 times 6 times 6 times z cubed. So we simplify that as 8 times the cubed root of 6z over 6z. And look at this. Our 8 and 6 can simplify to 4 over 3. So our final answer here is 4 times the cubed root of 6z over 3z. Oops, look at, there we go. Okay. Conjugating. So conjugating we do when we have 2 terms in the denominator, with one of them, at least one of them having a square root. So we need to multiply by the conjugate of this, which is itself, but with the opposite sign in the middle. So I'm multiplying by the square root of 5 minus 2 over the square root of 5 minus 2. And what we found, we distribute the 5, so we get 5 square root of 5 minus 10. When we have this conjugate, which is the same thing but just with an opposite sign, the middle terms cancel. So we're just looking at the first terms multiplied and the last terms. Square root of 5 times square root of 5 is square root of 25 minus 2 times 2, which is 4. So that simplifies into 5 times the square root of 5 minus 10 over square root of 25 is 5 minus 4 is 1. So notice there is no radical sign left in the denominator. Let's just do a little harder one. We'll do this last one. We're going to multiply by the conjugate, so it's the same thing. Square root of 12 plus square root of 3 over square root of 12 plus square root of 3. And could we have simplified the square root of 12? We actually could have. That's really 2 times the square root of 3. Okay, but let's just make sure we come up with the same answer. So we've got to do our FOIL on the top. So we get 2 times the square root of 36 plus 2 times the square root of 9 plus 3 times the square root of 12 plus 3 times the square root of 3. All of this is over the square root of 12 squared, which is 12, minus the square root of 3 times 3, which is 9. So the square root of 9 is 3. Okay, let's simplify the top and we'll be done with this problem. 2 times the square root of 6, so that's, 2 times the square root of 36, which is 6. That gives you 12, plus 2 times the square root of 9, which is 3, so 3 times 2 is 6, plus the square root of 12 can be simplified into 2 times the square root of 3, so 2 times 3 is 6, square root of 3, plus 3 square root of 3 over 9. Let's simplify one more time. 12 plus 6 is 18, plus 9 square root of 3 over 9. Oh, one more simplification. 9 goes into both of those, so 9 goes into 18 2 times, plus 1 times the square root of 3. And we don't have to write that 1. I just wrote it to show that we are dividing here also. Okay. Okay. I think that covers. Let's take a look. Adding and subtracting with fractions. Okay. Ugh. So if we want to add and subtract with fractions, we need to get rid of our denominator, to get rid of that radical in the denominator. So I'd multiply this by square root of 5 over square root of 5. And we get square root of 5 minus square root of 5 over 5. If I want to combine them, I have to make sure I have the same denominator. So I'd have to multiply both this by 5 over 5. So I have 5 square root of 5 minus the square root of 5 gives me 4 times the square root of 5 over 5. Okay, let's take a look at a simplifying one. When we have them divided, we can, that's the same as square root of 2 over 18. And we can reduce 2 over 18 into 1 over 9. And the square root of 1 is 1. The square root of 9 is 3. So that would reduce or simplify down to 1/3. Square root of 75 over the square root of 3, again, we can put them under the same square root sign because it's the same property. 75 divided by 3 is 25. So the square root of 25 is 5. And there you go. And this last one, we can actually ignore that. Well, yeah, we don't need to worry about reciprocals. Okay, we have covered all of those. One last thing that you might want to keep in mind. Square root of x times the square root of x equals the square root of x squared. And the square root of x squared is x, correct? However, if we took the cubed root of x times the cubed root of x, that equals the cubed root of x squared. We cannot simplify that any further. That's as far as you could take that. Okay, have fun with the homework.